Here we see Iguazio platform. We'll just dive into the services screen. See all those different services that run on Kubernetes as managed services and matrix and all of those. It's really easy to create site services. Let's pick one, this Jupyter Notebook service, and see its configuration. You can see it has resources, aspects of scaling and scaling down, security. And here I can just set the NFS volume claims, so that will be used in my service. Here we open our Jupyter Notebook service. You can see the NFS volume that we just mounted into it. If we want, we can actually synchronize that volume using few commands with using Cloud Sync. Let's go into a simple example. This is an NLP processing function that processes files and extract sentiments, translate them to a different language, and correct the text. So this is a very simple example. We can give it a file. This is an example of a file with good morning misspelled. If we run this function locally, we can see that it's clearing our text, setting the sentiments, and translating. We can even translate to other functions if we want. At this point, we want to turn it into a live real-time microservice. So the only thing we need to do is code to function, which translates our code from the notebook into a microservice. We want to attach it to the same NFS share that we are using here. So just one command. And we just need to deploy the function, which will automatically make it a microservice in Kubernetes, auto-scaling, high performance, and give us back the endpoint. We can actually look into the same function through the UI. You see it's a fully running, monitored, logged function. We can dive into the code. We can see the same code transported from our notebook into the function. We can see the configuration with all sorts of resources, allocations, all the things you can configure in Kubernetes, including our network share, our NFS share of the volume that this function is using to analyze the text files. We can set this microservice to listen on any type of trigger, whether it's HTTP requests, streaming, jobs, etc. This is another example of data analysis and machine learning to generate an AI model. In this time, we're going to take a function which was pre-baked and prepared before and stored in our marketplace. We're just going to import that function. We need to mount it into the same NFS volume so it will see the data. Give it some parameters like where the source file is, where to drop the outputs. The source file is relatively simple. It's an iris data set that's going into the training. I'm going to run this function. It will generate all those different nice plots for our analysis. I can view those plots in the same file share because it's going into the same place. This is an example of a feature analysis, feature histogram chart. Once I've done that, I want to run machine learning training, take the same file and generate a machine learning model. So just importing another function for training, applying this mount into that function and running it with new parameters, which algorithms, which parameters, which data set am I going to use, and where to throw the model output at the end. It's running, it generates all those nice matrix of my model. It actually generates a model file that I can use for serving this guy. If I want to see further analysis, I just click this. I can open the MLrun UI to see the parameters, the inputs that were used, all the artifacts that were generated, all the results of our model analysis, all the logs. If I want, I can take those functions and daisy chain them in a graph and create a full-blown pipeline with minimal amount of work that comprise of the data analysis, the training, and the deployment.